what happens when we declare a function as virtual or pure virtual within a class. Okay, so to understand this concept, we have to take a step back and first understand what is static binding and what is late binding. The concept of virtual function relies on late binding. Okay, now come back and understand what is static binding. So in case of static binding, when we declare a function and when we call a function, okay, so that linking between the function call and which function to be called in actual within an object is already defined. I mean, that is statically bound during but in case of dynamic binding, this is so at runtime only the decision is taken which function will be actually called, and that is the fundamental or the basic of dynamic binding. So it is very clear that static binding happens during compile time and dynamic binding happens during runtime. Okay, and in each of these cases, compiler is the one which does the static and dynamic binding to come into existence to have this concept in place. So it is all about compiler now. Once we understood, now we'll come back to the topic to understand what happens when we declare a function uh, as a virtual or pure virtual function. So in those cases, when a class is created, okay, and when there are a certain number of derived classes created out of it, and the base class has any virtual function, right? Then in those cases, in C++, what happens is the compiler creates a virtual table, okay, a virtual table for each of the class, and this virtual table is created for each of the class which has at least one virtual function. So if there is no virtual function, there won't be any this virtual table. Okay, and if there is one at least virtual function, there will be a virtual table for that particular class. So if we have 10 such classes which has virtual functions, at least one for each, then we will have 10 different virtual table, and each separate for the separate classes. And what this virtual table contains is, this virtual table contains the function pointer pointing to the function which are specified as virtual, okay, and which has to be called during runtime. And whichever function is already static, which means which are not declared as virtual, those entries will definitely will not be there. So each of to associate between the class and the virtual table, each of such class will contain vptr, which will be pointing to that specific virtual table. That concept is very clear. So if any class has virtual function, right, then that class will then there will be a virtual table, okay, for that particular class, and the association between the class and the virtual table will happen by a virtual pointer vptr pointer. And how things happens and all with an example. Now let's see in the code. Okay, so here I am creating an example. I have created a class which is a base class BBB. I have given the name to easily search and find why and all you will come to know later. So I have created a function ping in this which is printing some statement, and there's another class I've created, DDD, which is derived class from base, and it has normal function ping with the same name. Don't go about the statement, both are printing same statement, but we are not going to look into the output. We are going to see what actually happens when we compile this kind of what actually compiler does when we compile this kind of classes, base and derived class. So for that I have created a main class, main here, which has a pointer of type base, base type, and the object is created is of type derived. Okay, and I am calling ping from the derived. Now we'll compile this and see what is the output here. So here basically I've used one flag, fdump class hierarchy, okay, while compiling with G++. So here when we go and see, it will create a file, dot class file. So if we go and search for vtable, we have vtable entries, but those are not about this DDD or BBB. So there is no virtual table created for either a derived class or the base class. So so since we don't have any virtual function here, right, so we don't have any table here. So the class name is the intermediate file, okay, which is basically kind of dump, you can say. This is only for debugging. So vtable.cpp.002t.class, that is the file created apart from the output file, okay, which we can check it over here. Now I have we made this ping from the base class as virtual. Now if we go and check after compilation, we'll see this intermediate file. Then we can see vtable for DDD, right? So DDD vtable is created here now, right? So we had created virtual in BBB, and DDD vtable is created here as well, right? So vtable for BBB, so both base and derived has virtual table associated for ping function. Okay, so once we made a function as virtual, then there will be a table for base, and there will be a virtual table for derived, and each will have entry for this ping, because this was declared as ping. So there's a dynamic binding happening for ping here, and this virtual table within BBB is pointed by vptr. Okay, vptr is the one which makes this association of this virtual table with this class. These are the pointers and virtual table which will not be visible to us, will not be accessing it, right? This is all internal things. This is all about how things are compiled. So this is created as virtual. I will create one more function here now. So just see here. So there are only one ping entries, basically function pointers within the virtual table, right? Yes. So for DDD as well as BBB. Now what I'm doing, I'm creating one more virtual function, and okay, fine, let's make it non-virtual for time being, and give it another name, another ping. Okay, so and in derived class also I will create same function. Now still we will have two virtual tables, sorry, there will be two virtual tables, right? Another ping I'm calling, so it will not make any difference from the main. But if you see, there will be two virtual tables, because ping is declared as virtual, but we don't have another ping entry here, right? So this virtual table, each of this virtual table has entry only for ping, not for another ping, right? Because this is not declared as virtual, so there is a static binding, so there is no entry in the virtual table here. Now what I will do is I'll create this also another ping also as virtual, and that's it. Now I will compile it. Okay, we'll compile it, and now let's see, we'll reload. So there are two entries within this virtual table. Okay, one is for ping, one is for another ping, and this is for in both base class as well as derived. So each derived class will have this virtual table now. And there is, you can see there are few more function pointers within this right, within this virtual table. So that is those are other things. So those are anyways will not discuss right now. Fine. So there is a virtual table, and there is a vptr in each class, and those vptr has specific values. You can see JTV3 triple B, and that is if you see this vtable vptr equals to address of triple B colon ZTV3BB, right? And that this virtual table name is that, right? So the address, the virtual table association is done over here, right? Yeah, so this thing is very much clear, right? So there is a vptr. It is vptr is holding address of the virtual table, and then virtual table has the entry of each of the function which is declared as virtual in the base class. And if whether you write override or not, it will not make difference, at least in this virtual table. So override is only for code readability, but how internally virtual works, it doesn't get affected by the keyword override here. Yes, so the version of G++ I'm using is 7.5. okay, so if it is up to that 7.5, then the flag is fdump -class -hierarchy to get this intermediate